In this lesson, we're going to find and kind of define what are called the reciprocal trig ratios. All right, so here we have a right triangle. This leg is 6, this leg is 8, this leg is 10. It's a right triangle. We know the original 3 trig identities: sine, cosine, tangent. And you could say, so in this particular example, if we were asked to find the sine of x, we could say, all right, well, the sine of this angle x is opposite over hypotenuse. It'd be 6 over 10. The cosine of this angle x, that's adjacent over hypotenuse, it'd be 8 over 10. And the tangent of this angle x, that's opposite over adjacent, that would be 6 over 8. Right, because we have our opposite leg. This leg is opposite of the featured angle x. This leg is adjacent to the featured angle x. This is the hypotenuse, of course. All right, so we're good with these. We know these. This is SOHCAHTOA. These are the original 3 trig identities. So what are the reciprocal trig identities? Well, the word reciprocal indicates that you're kind of flipping this fraction upside down. All right, so let's start with what's called cosecant. Cosecant, CSC, the cosecant of angle x, is the reciprocal of sine, which means we flip these upside down. It would be hypotenuse over opposite. So instead of, in this particular example, instead of 6 over 10, this would be 10 over 6. The next one is secant. Secant is the reciprocal of cosine. Instead of adjacent over hypotenuse, it's hypotenuse over adjacent. So in this particular example, that would be 10 over 8. And then the reciprocal of tangent is actually called cotangent. So it's the reciprocal of tangent. It would be adjacent over opposite. So in our particular example, that would be 8 over 6. Okay, and let me write, these are the abbreviations for cosecant, secant, and cotangent. Let me write those out for you. There you go, there's all the words written out. And you know what, let me do the same for these as well. So if you're going to take a screenshot of anything on this video, this is the most important thing right here. And then just a quick note with, when you evaluate what a trig identity is equal to, you know, sometimes you'll leave it as a fraction. Like you could simplify this as a fraction. And then sometimes it's just converted into a decimal as well. So you could say the sine of this angle x is 3/5, or you could say 0.6. This you could reduce it, you could write as a decimal, 0.8, 0.75. Likewise with your reciprocal identities, same thing. You could like simplify this as a fraction, 5/3, or in many cases it's written as a decimal. That's about 1.67. This would be 1.25. This would be 1.33 approximately. So they can kind of be written either way, either as a fraction or as a decimal. Now in question 2, you kind of see this on full display. Questions 2 through 5 says, find the value of each trig function when given a corresponding trig ratio round to the nearest thousandth. And here it says, find cotangent of theta if the sine of theta is equal to 3/5. Now this is kind of interesting. Here they're giving you the sine as this fraction, 3/5, or as a ratio. But you can see from the choices, they want you to write your final answer as a decimal to the nearest thousandth. That's okay. Here's how we're going to do this. So when we're given the sine of theta is 3 over 5, we have to remember the 3 stands for the opposite, and the 5 represents the hypotenuse. Okay, so I would recommend at this point, let's go ahead and draw a triangle. And we'll have this angle, reference angle theta. It's a right triangle. And let's go ahead and put an opposite leg on this triangle. It doesn't have to be to scale, okay? This is not to scale at all. But let's draw an opposite leg of 3 and then a hypotenuse of 5. Okay, so this triangle now matches the ratio that I have of this angle theta. Well, we're going to now use Pythagorean theorem. We do not know what the adjacent leg is. It's not given to us. But with Pythagorean theorem, we can find it really easily. Remember, Pythagorean theorem just says that, so guess what, I'll just call this x right here. So we're going to find this missing leg here, the Pythagorean theorem. So it would be x squared plus 3 squared is equal to 5 squared. So x squared plus 9 equals 25. Subtract 9 from both sides. Okay, you all remember the Pythagorean theorem. It wasn't too long ago we were studying Pythagorean theorem. So we found that the adjacent leg here is actually equal to 4. Okay, the adjacent leg is 4. So if my opposite is 3, my adjacent leg is 4, my hypotenuse is 5, well, guess what? Now I can find any of these trig ratios that I might want. Okay, so I'm going to go through and list all of them. I'm going to list them all. Now the reality of this particular problem is you only need to find the cotangent. But you know what? Let's just kind of review them all real quick. So sine is opposite over hypotenuse, 3/5. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So there's kind of the fractions for each of these trig identities. And then let's look at our new guys. Cosecant is just the reciprocal of sine. It'd be 5/3. Secant is the reciprocal of cosine. It would be 5/4. And lastly, cotangent would be the reciprocal of tangent, 4/3. Yes, I know I'm an overachiever. I did not need to find all of those. I just needed to find cotangent. So if I divide in my calculator, this is what it would look like as a fraction. If I divide my calculator 4 divided by 3, you get approximately 1.3333. And so that is the answer I was looking for. Okay, so hopefully with this example, hopefully you're good on finding 3, 4, and 5. And one last quick note on this. Sometimes students will ask me, they'll say, Mr. Klein, how can I remember cosecant is the reciprocal of sine? And how can I remember that secant is the reciprocal of cosine? Well, you'll notice sine and cosine start with an S. Sine starts with an S, cosine with a C. Well, over here, it's just you take the reciprocal of that. Here, your first one is going to start with a C, and your second one is going to start with an S. And so I just always kind of visualize this. If sine is on my top line and cosine is on my second line, then I'm going to flip it over here with my reciprocals. I'm going to put cosecant on the top line and secant on my second line. So that's one way. That's always kind of helped me remember in my brain. Maybe you have your own way that works for you, but best of luck on this assignment. Bye.